Hello guys, so we're going to tackle about the lesson 6 fuel. So there are solid fuels under characteristics and liquid fuels under characteristics and gaseous fuels under characteristics. So that's we're going to tackle on this video. So what is fuel? So fuel is any substance that when it burns, it produces heat. Now, for a substance to be considered a fuel, it must contain elements that can burn, such as carbon, hydrogen, and sulfur. During burning, the chemical energy stored in the fuel is released as a heat energy. So, fuel is just a substance that when it burns, makaproduce ra siya og heat, but using carbon, hydrogen, and sulfur. So, to make the energy from fuel more useful, it often needs to be transformed from one state to another. So, how can we transfer it? So, for example, a solid fuel may be changed into a liquid or gas. So, if a fuel, we're going to transform it into make a energy. So, example of that is the chemical energy of the fuel can be converted into another form of energy, such as mechanical energy, as you can see, and electricity through various processes. So, by converting fuel into more useful energy. So, that's the fuel. Next, what is solid fuels under characteristics? So, solid fuels under characteristics are mainly classified into two categories. Example, natural, it classifies that fuel such as wood and coal. So it manufactured fuels such as charcoal, coke, briquettes, and etc. So what's the advantage of it? So they are easy to transport. So as you can see, fuel such as log or wood or coal, so it's easy to transport because it's not hazardous and more efficient. So next is they are convenient to store without any risk of spontaneous explosion. Ilahi ra sa kanang mga like gases because it will use to store it properly para dili siya mo spontaneous explosion. Their cost of production is low. Next, they possess moderate ignition temperature. So that's the advantage of solid fuels. So what is the disadvantage of it? So the disadvantage of it is their ash content is high kaysa sa gas fuels. So when it's come to solid fuels, their ashes content is high kay it use coal or kaning woods, and their large proportion of heat is wasted, not likely sa pareha sa kaning gases. So next, they burn with clinker formation. Their combustion operation cannot be controlled easily, unlikely sa gas nga makontrol ra nimo ang kakusog sa combustion sa kanang heat. Next, their cost of handling is high. So that's the disadvantage of it. So next, coal under characteristics. So what is coal under characteristics? So coal is a mineral that came from plant material that has been transformed over millions of years in India. Large coal deposits are found mainly states like Bengal, Bihar, and Madhya Pradesh. However, most of the coal in India of lower quality. To improve its quality, especially to get coal with less ash, for use industries like iron and steel manufacturing, coal needs to be cleaned through a process called washing. So, more than 30% of India's coal is used by railways, and similar amount is used by industries, particularly for making iron and steel. This leave only about 40% of the coal mined available for generating electricity through power plant. So, that's the coal and their characteristics. So, analysis of coal. Two commonly used analysis of coal are proximate analysis of coal and ultimate analysis of coal. So, we're going to define what is that two. So, what is calorific value? Calorific value of coal is defined as the quantity of heat given out by burning 1 unit weight of coal in calorimeter. So, we're going to find out what's that two. Proximate analysis of coal. So, what is proximate analysis of coal? So, in the PPT, this analysis of coal gives good indication about heating and burning properties of coal. And ash content is found by completely burning the sample of coal in muffled furnace at 700 degrees Celsius to 750 Celsius. Weigh the residue and etc. So, proximate analysis provide essentially insight into the heating and burning characteristic of coal. It assesses four main components: moisture, volatile matter, ash, and fixed carbon. These properties are critical for evaluating coal quality and its suitability for various industrial and applications. Proximate analysis is crucial for assessing coal suitability for specific applications, such as power generation, metallurgical processes, and heating. The result helps in classifying coal and predicting combustion behavior. So, that is the proximate analysis of coal. Next, what is the ultimate analysis of coal? So, this analysis of coal is more precise way to find the chemical composition of coal with respect to the element like carbon, hydrogen, oxygen, nitrogen, and sulfur and ash. So, since the content of carbon, hydrogen that is already combined with oxygen to form carbon dioxide and water is of no value for combustion, the chemical analysis of coal alone is not enough to predict the suitability of coal for purposes of heating. So, the chemical composition is very useful in combustion calculation and finding the composition of flue gases. So, ultimate analysis provide a detailed chemical composition of coal by determining the proportion of carbon, hydrogen, and oxygen, and also nitrogen, sulfur, and ash. This method offers precise understanding of the elemental makeup of coal. So, combustion analysis, ultimate analysis is critical for combustion calculation as it determines the potential for energy generation and efficiency in burning. So that is the chemical composition is very useful in combination calculation. So that's what it is. So next is while this analysis given precise chemical composition, it does not directly account for the energy contribution from component already combined with oxygen. Example, carbon dioxide, or water. Thus, proximate analysis often used in conjunction to assess overall suitability for heating. So, that's all about the disadvantage and advantage and analysis of coal, and my partner will going to discuss the others. So thank you and bye.
Let's continue the lesson 6 with liquid fuels and their characteristics. Advantages of liquid fuels: they possess higher calorific value per unit mass than solid fuels. So, what is higher calorific value means? So, the higher calorific value or gross calorific value is value includes the heat released when the water vapor produced during combustion is in liquid state. It accounts for the total energy released, including the latent heat evaporation of water. The calorific value, also known as heating value or energy content, is a measure of the energy released during the combustion of a substance. It quantifies the amount of heat energy produced per unit of substance. Calorific value typically expressed in units like joules per kilogram or British thermal units per pound. They burn without dust, ash, clinkers, etc. Their firing is easier, and also fire can be extinguished easily by stopping liquid fuel supply. They are easy to transport through pipes, can be stored indefinitely without any loss. They are clean in use and economic to handle. Loss to heat and chimney is very low due to greater cleanliness. They require less excess air for complete combustion. They require less furnace space for combustion. While the disadvantages of liquid fuel, the cost of liquid fuel is relatively much higher as compared to solid fuel. Costly special storage tanks are required for storing liquid fuels. There is a greater risk of fire hazards, particularly in case of highly inflammable and volatile liquid fuels. They give bad odor or efficient burning of liquid fuels. Specially constructed burners or spraying apparatus are required. So, the petroleum and its characteristics. Petroleum is a natural dark, greenish-brown thick liquid found deep within the Earth's crust. It is primarily composed of hydrocarbons, which are organic compounds made of hydrogen and carbon. In addition to hydrocarbons, petroleum also contains small amounts of other organic compounds that include oxygen, nitrogen, and sulfur. Petroleum are graded according to the following physiochemical properties: A. Specific gravity, B. Calorific value, C. Fish point or ignition point, D. Viscosity, E. Sulfur contents, F. Moisture and sediment content, G. Specific heat and coefficient of expansion. The classification of petroleum. The chemical nature of crude petroleum varies with the part of the world which it is found. They appear, however, to be three principal varieties. The paraffinic-based type crude petroleum. Paraffinic crude oil is a crude oil that is predominantly contains straight-chain alkalines or paraffin. Then there's the asphaltic-based type crude petroleum. Oil containing asphaltic material but very little or no paraffin wax. This type of oil is suitable for making gasoline, fabricating oil, and asphalt. And there's the mix-based type crude petroleum, which is the mix of paraffinic and asphalt petroleum. It is a predominating solid residual. Crude oils are commonly classified according to their respective distillation, which reflects the reflective contents, three basic hydrocarbon structural types: paraffins, naphthenes, and aromatics. The gaseous fuels and their characteristics. The gaseous occur in nature besides being manufactured by solid liquid fuels. The advantages: they can be conveyed easily through pipelines to an actual place of need, thereby eliminating manual labor and transportation. They can be lighted at ease. They have high heat contents and hence help us in having higher temperatures. They can be preheated by the heat of hot water gases, thereby affecting economy in heat. Their combustion can readily be controlled for changes in demand like oxidizing or reducing atmosphere, length, flame, temperature, etc. They're clean in use. They do not require any special burner. They burn without any soot or smoke and ashes. They are free from impurities found in solid and liquid fuels. While the disadvantages of gaseous fuels, their very large storage tanks are needed. They are highly inflammable, so chances of a fire hazard and their use is high. Natural gas is generally associated with petroleum deposits is obtained from wells dug in oil-bearing regions. The approximate composition of natural gas is CH4 equals 70.9%, C2H6 is equals to 5.10%, H2 is 3%, and CO plus CO2 is equals 22%. It's a colorless, non-poisonous gas with a calorific value of 12,000 to 14,000 is widely used as a domestic fuel and can be transported over long distance through pipelines. It is commonly available in America and is also used in chemical manufacturing. A specific gravity ranges from 0.57 to 0.7. And that's it for lesson 6. Goodbye.